Talk about vectors. Vectors are quite often used in physics. They have two functions. First of all, they have magnitude, and they also give us an angle. Now, when we're working in one-dimensional situations, we just have either negative or positive. But when we get into two-dimensional and even three or four dimensions, then we need something much more. Now, we're going to be talking about XY, a two-dimensional plane, okay? We have a vector anywhere in this plane, okay? Now, this vector, it can be described a couple different ways. First of all, we have magnitude. So let me just draw a vector here. That's so straight. The length of the vector, this is the magnitude, okay? And this vector is pointing in the direction that it needs to be pointing in. So let's take a look at this vector r right here, okay? The vector r has a certain amount of degrees from the positive x-axis that we define it, and we also can define it by its magnitude. Those are basically called polar coordinates, okay? But we can also look at magnitude and angle another way too, and that is by vector components. So in this case, let's talk about r. What are the vector components? Okay, well, they are x and y, okay? Now, if we called r, this little r, if we called it big R, okay, we would put an arrow on top is equal to r of x plus r of y. This would describe this vector, where the r's of x and r's of y is the components of this vector r. Okay, now let's say we know that, I'll put up some numbers here. Let's just say that x, or r of x, is equal to 5, and ry is equal to 4. Okay, and we'll say the units are meters for both of those. Okay, so we have defined two vector components. Now let's just say, for example, if we had two vectors, we could just add up the vector components, and then we would get what we call a resultant vector, which I'll show a little bit later down. But we can define this vector either as vector components or also as polar coordinates. So what are the polar coordinates? Now, sure, some of you had this in math. Okay, polar coordinates is where you're given an r and an angle. Okay, so we can also describe this vector with an r, or a magnitude, and with an angle. And how do we find that? Well, we find it by taking r is equal to the square root of x squared plus y squared. Okay, and this just comes from the Pythagorean's theory of r squared equals x squared plus y squared. Okay, so let's do this up here. So r, and we denote this that we're talking about its magnitude, is going to be equal to 5 squared plus 4 squared. Okay, and take the square root, and that's going to give us 6.4 meters. So that is the magnitude of this vector, 6.4. The only thing we knew before was it had its components, its y component and its x component. But now we know the magnitude. But what else do we need to know? Now, for all these, except for the inverse tangent, all these, we need to know what the angle is. Now, we could find the angle since I already worked out what r is right here. Okay, we have r, you have x, and you can simply find the angle. Okay, now how you find the angle with this is that you're going to have to use the inverse cosine. But you really don't need to go through all that. So let's move on. We're going to use this right here to find our angle. Okay, so let's do that. The tangent, the inverse tangent of would be 4 divided by 5, and these are both meters, is going to, turns out to be 38.7 degrees. So that is our answer right there. So we have 38.7 degrees from the positive x-axis rotating counterclockwise. All right, let's take a look at adding two vectors. So I have vector A plus vector B, and I'm going to add them. We're going to call the vector, the new vector, we're going to call that vector R. Okay, so let me draw a coordinate system right here. So when we add two vectors, let's say we have, this is a vector, and this is B vector. Given the polar coordinates of each vector. Okay. So let's see what the data is. Okay. So for the magnitude of a vector, and put two lines on either side that designates the magnitude, is equal to 10.0 meters. And then for what about the B vector, that is going to be 12 meters. Okay. Now we also need the angle that each vector is counterclockwise from the positive x-axis. Okay, so we're going to call for a vector, we're going to use theta is equal to 45 degrees. And for the b vector, we're going to use a Greek letter called phi, and that is 60 degrees. So now we need to find the polar coordinates of vector r. So we need to add the two vectors, A and B. So how do we do that? Well, first of all, let's look. Remember that vector r, or any vector, is going to have its vector components. R of x plus r of y. Okay. So to find r, we're going to need to find its components. So let's go ahead and do that. So let's start with r of x. Okay. So r of x is going to be equal to the magnitude of a, the cosine of theta, okay, plus what else? Well, it's going to be the magnitude of b cosine phi. Now all this is a cosine theta, b cosine phi. Those are just the components of the x-axis, right? Because if we start talking about finding, let's just say cosine of theta is equal to rx over r, okay, then basically if we wanted to find rx, we take r cosine theta is equal to rx. Okay. In this case, we're trying to find rx, so we're using a cosine. So in this case, you would have a cosine theta comes from cosine theta equals a over a of x. I'm sorry, this is backwards. A of x divided by a, okay. And so this becomes a cosine theta equals a of x. So here we have a of x. This is representing a of x. And this is representing, sorry, b of x. So we have all the x's there. We're just adding them up. So let's go to ry, I'm sorry. And this is a. And now you notice we have the sign because we're working with the y. Okay, theta. Now we have the b vector. And that's going to be sine 2. What we're going to use the angle phi. Okay. Now I'm not going to go through the math on this. You can do this on your own. But for Rx, you will get 13.07 meters. And for Ry, you will get 17.04 meters approximately. Okay. So what do you do next now that you have solved Rx and Ry? Well, you need to find the magnitude, and then you need to find the angle of the new vector. Now, when you add vectors, just remember when you're adding two vectors, we have vector A right here, which is at its angle, and then we take from tail to head of B, whatever that is, okay, and this is from here to here is our new vector. And let me just draw that out so we can see it a little bit better here. I'm going to make it more distinct. Okay, so we have one vector like this and one vector like this. Okay, we'll say this is our A, we'll say this is our B vector. So we add them head to tail. Even though both vectors, the tails are connected to the 0, 0 point on the XY axis, how you add them is this way. And then so the resultant vector, in this case, the resultant vector starts from the tail of this vector and goes all the way up to here. And that is really pretty bad. So let me do it again here. Hopefully. Okay, so this is our This is, we'll make this B and we'll make this A. So R is our new vector. Now it has, if it's in a coordinate system, okay, it has its own angle too. We can call this angle theta of R, okay? And so we need to find the polar coordinates of it. So that means the magnitude, and that means the angle that is from the positive x-axis. So let's do that first. So the first thing is the magnitude of R is going to be equal to the square root of Rx squared plus Ry squared, okay? And so what is Rx? Rx is 13.07 squared plus 17.04 squared, all under the square root. And this gives us a magnitude of 21.5 meters. Okay, so that is the first of our two answers that we need. So this vector has a magnitude or length of 21.5 meters. What about the angle? Okay, let's do it down here. Angle, tangent, minus 1 of Ry divided by Rx equals theta. So let's do the problem. So Ry is 17.01, I'm sorry, 4, and 13.07 divided, this is going to be equal to the angle. And the angle comes out to 53 degrees. So we now have answered both what R is. R has a magnitude of 21.5 meters, and its angle is off the x-axis. Okay. Now let's take this same problem and let's do a scenario where we have a new resultant vector is equal to A minus B, and we want to solve what that is, okay? Well, first of all, there's no such thing as a negative vector. So what we're going to have to do, we're going to rewrite this the right way. A plus negative B, and that's just talking about the direction. So how does that work out? Let's take a look at what we have here. So I'm going to put vector A in red. Well, I'll put it in green because it's green and black, but I'll use green and red for each one. Okay, so vector A is there, and then we had vector B. I used red for that one. Vector B was something like that. Okay, but now this is a negative vector. Okay, so you're actually, in this case, you're going to inverse this vector. Now the magnitude is not going to change. What's going to change is the direction. Now we said that we were given that vector B its own, I don't think we solved, yes we did, I'm sorry. We were given that vector B is 60 degrees. Okay. So let's write this in. Vector B was 60 degrees for its angle. But now it's going to be plus 180 degrees because we want to inverse it, okay? And which that comes out to 240 degrees, okay? Vector A is not going to change. It's just going to be this right here is going to change. The magnitude will be the same. So our B vector now is going to be a negative, okay? So when we add up that, let's go back to here, and we look at specifically the B in both Rx and Ry equations, okay, this B cosine phi, okay, is going to be a different angle. Here we were using 60 degrees. Now we're going to plug in 240 degrees, okay? And that's going to give us a different answer. Rx, I'm going to set these up so you'll get some idea what has to be done. We have A, the cosine of 45 degrees, plus B, the cosine of 240 degrees. And then we have A, the sine of 45 degrees. I'm sorry. Yeah, 45 degrees. And plus B, the sine of 240 degrees. Okay. This one right here is going to be equal to 1.06 meters, and this one is going to be equal to -3. Okay, and so then we do the same thing. We're going to take and find the magnitude, since we have these now. We have 1.06, this is squared, plus -3.32, this is squared, and this gives us an answer of, I believe, of 3.5 meters. And what about the angle? Okay, we have -3.32 meters divided by the x, 1.06. Okay, and so this is going to give us some crazy answer. Now, one of the things in this part right here, you want to take note. Okay, remember, this is y over x. Okay, you have a negative y and you have a positive x. So that's going to give you an idea of what quadrant this resultant vector is going to be in. Okay, it's going to be where the y is negative and where the x is positive. So where is the y negative and the x is positive? Okay, well, it's going to be in 1, 2, 3, quadrant number 4. Okay, so this vector is going to be something like this. Resultant vector right on the edge there. It's going to have minus 3.32 component, y component, and it's going to have a 1.06 x. So this is the resultant of B, A minus B. Okay, and the angle comes out to 72.2 degrees, minus 72.2. 0.2 degrees. But this is not the answer. This is not your answer. It's minus 72. So how do you find that answer? Well, you find this answer by realizing, okay, it's in this quadrant right here. It's in here. So you have to rotate minus 7 or 72.2 degrees clockwise now. Remember, clockwise is negative always. Okay, and then counterclockwise is always plus. So we're going to go clockwise, and so we're going to go negative. Minus 72, actually, we can just take minus 70. We can take 360 degrees minus 72.2, and we can get our angle. Okay, that's 287, approximately 288 degrees. Okay, so that's the answer. Our magnitude does not change. Well, I'm sorry, our magnitude does change. It's actually 3.5. So our magnitude does change. So we have these two results right here. As compared to the same vectors that were added together, up here we had a magnitude of our 21.5 meters and 53 degrees. And then when we subtract them, we have a magnitude of 3.5 meters, and we have an angle of 288 degrees, which this makes sense right here because you have what? You have 0, 90, 180, 270. This is 288, so it's a little bit to the right of the negative y-axis. Okay, that's it on for vectors, and I should be making another video on projectile motion. Thank you.